Okay. Here, so this is the idea. We're gonna introduce the idea. I'm not telling you how many boxes there are. I'm gonna make you think about it. Okay. So the topic of this discussion is called similar solids. So here we're gonna take a vote. I've drawn for you. What are the two shapes I've drawn for you? They have one name. What are those two shapes? Those are two cylinders. Okay. There's one on the left. It's kind of like a short, fat one, and there's one on the right, which is like a kind of like a tall, thin one. Okay. The question I have for you that you're gonna think about for 30 seconds. That's a long time to think in your head for 30 seconds by yourself without talking. Here's the question. The answer is either yes or no. Are those two figures similar? 30 seconds begins right now. Okay, the question I asked you was, are those two figures similar just from the pictures that you see? Hands up if you say, yes, they are similar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let the record show that 15 people are voting yes, that is similar. Hands up if you say, no, those are not similar. Let the record show that two are voting for no. Okay? That's the grand total of everybody in the room, so everybody voted. Good, I'm glad. Okay, great. We're going to come back to this, okay? I'm going to keep that in mind. Watch this. Here's what we're going to do. We're going to keep this on here so that everyone remembers how we voted. Okay, there it is. And we're going to do this. We're going to put you smaller, and we're going to put you right there. Okay, that's how the class voted. Over in the, above the question mark. I like that. Okay? That'd be funny, huh? So, let me give you some dimensions now, okay? So, on the dimensions, let's say that the radius of this was 10 inches, and the height was 3 inches, and the radius of this one was 2 inches, and the height of this is 12 inches. Okay? Do the measurements help you make a decision, or do they not matter? They do. You say they do help you make a decision. Okay? So what does it mean to be similar solids? It means two things. Okay? Similar solids. This is an important part. So to be similar. To be similar. Yeah, the radius of that one. Yeah. Okay? Two things have to happen. Number one and number two. Number one's easy. The bases must be similar. The bases of the objects. They must be similar. So let's go back and look at our drawing here. What is the shape of the base of each of these? Circles. So are all circles similar? Yeah, they have the same shape, right? They're all, so that's an easy one. Okay, that's an easy one. The bases are already similar. Number two, this is where the complicated part comes in. The heights must be the same ratio as the scale factor of the bases, the similar bases. Okay. So, what does that mean? The heights have to be in the same ratio as the scale factor of the similar bases. So here's what we're going to do. I'm going to move this up. We're going to examine for just a moment. I'll check different color here for you. And we'll go here. Let's talk about the bases of these two figures, okay? The bases are in a scale factor of 10 to 2. 10 to 2. If I simplify that, I would get a scale factor of 5 to 1. Are you guys cool with that? Did I do anything trickery? Any trickery there? Witchcraft? No? We're all good? You guys agree? Okay, that's the scale factor of the bases. Now let's take a look at the heights. The scale factor of that would be 3, measuring the same direction. 3 to what? Which implies, what's the ratio there? 1 to 4. Are these the same? No, they are not the same. Therefore, the 2 of you who voted no were correct, and the 15 of you who voted yes were incorrect. Okay, let's take a look at these. You're given two cones here. Okay, that's 24. We're trying to determine if these cones are similar, if these solid cones are similar. So the first thing we have to check is, are the bases similar? Yes, because all circles have the same shape, so they have to have the same shape. Okay? So yes, the first thing is part. Now here we're gonna do. Let's check the ratio of their similar bases. So if I check the ratio, it would be 8 to what? 8 to 12. If I simplify that, what would that give me? We'll move this over. Which implies a 2 to 3 ratio. Now let's take a look at their height. Going in the same direction, if I go from 8 to 12, I better go 16 to 24.
16.
Yeah, that's the height of this one. 16 to 24. So what does that simplify to? 2 to 3. Are these the same?
Yeah.
So their scale factor, right? The heights are in the same ratio as the scale factor of the bases. That's what number 2 says up here. Their heights are in the same ratio as the scale factor of their bases. So therefore, do you have enough information now to say that these two pyramids are or not pyramids, cones are similar? Yes, they are. So I like to do that. That cone is similar to the other cone there. The smaller one to the bigger one. Okay, let's talk about ratios of solids here. Ratios of solids. Okay. If you're given the A to B ratio, is the ratio of, this is going to be your ratio of your scale factor or anything that's measured in linear units. Oh, I forgot the A. Sorry. And anything that's measured in linear units. So what is a linear unit? Slant height, that's a linear unit. Circumference, that's a linear unit. Diameter, that's a linear unit. Radius, that's a linear unit. Okay? All of those are linear units. Scale factor is a linear unit. Does that make sense? And when I linear, I mean line, like this line to that line. Does that make sense? Okay? What do you think that second one down there is for? The ratio of what?
Area.
Very good. Very good. The ratio of areas. Now, what gives it away? What gives it away? The squared. Very good. Awesome. You guys are doing great. Now, Ben can put it together, man. Keep going. You got it. That's the ratios of volumes. Absolutely. So, we can jump from line to line given any of these informations, right? And that's what we're going to practice right now in this next little example. I'm going to shrink this down so we still have a box handy. I love that. Isn't that nice? And then I'm going to actually draw a picture for you here, okay? Okay, what is the picture that I just drew for you trying to say? Isa. Yeah, the two cones are what? Similar, because that little thing inside there is similar. Now, it might not say that for you on the test or quiz. In that particular, it won't look like that, but it will tell you, hey, this cone and that cone are similar, okay? Question. Okay, here's what I'm going to do. I'm going to give you some information. I'm going to tell you that the area of this base is 4 pi meters squared. I'm going to give you some information. The area of that base is 4 pi meters squared. I'm going to give you some other information. Say the area of this base is 9 pi meters squared. And I've already told you that the two figures are what? Similar. I have told that to you already, right? Okay. So here's what we're going to figure out. We're going to make a list. So we're going to find the ratios of the following, ... Number 1, the ratios of their radii. I'm gonna put the list up here so you can see. 2, their lateral areas. 3, their heights. 4, their total areas. 5, their volumes. Yes, it is. And meters squared. And 6, their slant height. Now remember, we're finding the ratio of these from one figure to the other if we know the figures are similar and we know their areas of their bases, okay? So here's what we need to do. We need to create this chart. Before we start answering these questions, we got to make this chart over here to the left, or the right. This is the right, huh? Okay. Here we go. I know this is going to be my a to b. This is going to be my a squared to b squared. And this is going to be my a cubed to b cubed. All right? What is the part that I know? What do I know? Yeah, I know the ratio of their areas, right? One's 4 pi meters to the other is 9 pi meters. If I write 4 pi divided by 9 pi, what do I get?
4 nines.
I get 4 to 9. So that one goes here, 4 to 9. So a squared must be a value of 4. Therefore, a must be a value of what? 2, right? If b squared is 9, then b must be what? 3, very good. Okay, now, if a is 2, a squared is 4, a cubed must be 8, very good. 3, if b is 3, b squared is 9, then this must be 27. Okay, now, we have all the information that we need, and I'm going to write these in green. So let's get the ratio of the radii. Is radius, is that a linear unit, a squared unit, or a cubed unit? It's a linear unit, so what would the ratio of the radii be? 2 to 3. Do you guys get this now?
Yeah.
Okay, what's the ratio of their lateral areas? 4 to 9. Very good. Ratio of their heights? 2 to 3. Very good. Ratio of their total areas? 4 to 9. Ratio of their volumes? 8 to 27. I love it. And finally, their slant heights would be what? 2 to 3. Now, do you understand what I mean by linear stuff and scale factor? Okay, so here's the setup for this problem. I've given you two similar rectangular pyramids. The height of the smaller one is 3 centimeters. The height of the larger one is 5 centimeters. I have told you that the total area of the smaller pyramid is 81. I would like you to figure out the total area of the larger pyramid given the fact that they are similar and you know the scale factor of their heights. Do you understand what I'm asking you to do? Yeah. Okay, I want you guys to try it right now with a partner. Ready, set, go. Ladies and gentlemen, here we go.
X equals 225 centimeters.
Very good, very good. So we know this. We know we have a linear scale factor, don't we? The linear scale factor we have is this, 3 to 5. Do you guys agree with that? Yeah. That's a linear scale factor of their heights because they are similar. I told you that. Is that true? Yeah. Okay, good. Now, if a is 3, then a squared must be what? 9. Good. And if b is 5, 5 squared must be? Good. Let's take it one step further. If a is 3, a squared is 9, a cubed must be what? 27 to 125. Now, here's what everybody did, okay? You guys, I asked you for area. So which one are you going to choose to set your ratio equal to? The second one, not the first one. Do you see where we made the mistake? Okay. So I want a total area. So here's the deal. The area of the smaller one, 81 to the thing that I'm looking for, which I'll call it x for now, has to be set to 9 to 25, not 3 to 5. Do you see what happened there? Yeah. Good. If we solve this, you get an answer of 225 centimeters squared. Okay? Now, we're going to take this one step further. Okay? Check it out. I'm going to give you some more information. This is good information to have. I'm going to tell you right here. The volume, the total volume of the big guy is 1,625 centimeters cubed. Give me the volume of the little guy.